This is Mr. Anderson for Keller Community College. Math 121, Chapter 5, Section 8, the applications of polynomial functions. Today we're going to actually look at the reason why we factor, and the main reason why we factor is that you will probably have up to 2 solutions for any problem with an x squared. An x cubed, if that's in the problem, you'll have up to 3 solutions or up to 4 solutions for x to the 4th. And the real reason why we factor is to really solve for x. And we're going to solve for x and when x hits the ground or when x is equal to 0. So all of these equations we're going to be set up so we have problems set equal to 0. So you'll see that that's in the case of these first two because the graph, when put into the graphing calculator, is either going to look like it hits the ground or crosses the x-axis twice at these 2 spots, or it crosses the x-axis at only one spot where it comes down, connects at one spot and then goes back up, or it doesn't cross at all. And this would be an example of a problem that has no factoring available, or prime factoring. So the best thing about this is that I'm going to show you the pictures on the calculator in kind of reverse order. I'm actually going to show you what the graph looks like and then how you would factor and get those answers. That's actually reverse of what I would do in a normal class, because I would want to factor first and then show you the calculator work. But since the calculator work will disappear all the written work on the screen, I'm going to kind of reverse the process here. So our purpose today is to solve for x, or find out when x hits the ground. And these will be equations that either intersects up to the number of powers that you have. So as a general rule, if you have an x squared, you'll have up to 2 solutions. If you have an x cubed, you'll have up to 3 solutions. And if you have an x to the 4th, you'll have up to 4. And we're going to get into some of the simple ones right here. So here are the rules for solving for x with polynomials. The first rule is you want to set the equation, or set whatever your problem is, equal to 0. Set the problem equal to 0. Step 2, you're going to then factor it. And then once you factor, you're going to then solve for x. And it's definitely, there's more steps involved if you had to write out every single piece of this, but you'll kind of see as we go along here how to do it. So as promised, what I'm going to do is I'm going to type this into the graphing calculator and show you what the first one looks like here. So let me get my calc on the screen here. Then I'm going to go to my y equals, and I've cleared my memory just in case my tables and setups will be, okay. So let's go to my y equals. I'm going to type in my 6x squared minus 15x. And then I'm going to go to my graph. Now, it looks like my intersecting points, where this crosses the line, it crosses the line at 0 and about 2.5. Now let me show you how that's going to appear as we do our factoring. Now, according to our factoring rules, the first thing we should always do is look for a common factor. So the common factor in this problem is going to be 3x. I can pull 3x out of both of these terms here, and that gives me 2x minus 5. I'm left with a binomial in this problem. Now, this is not a difference of squares, nor it is a sum or difference of cubes. So I'm done technically factoring all of this. So now that I'm done, I'm going to solve for x by setting this and this parenthesis equal to 0. This is going to give me my 2 solutions. So 3x is equal to 0 and 2x minus 5 is equal to 0. I'm going to solve for x now. Dividing both sides by 3, x is equal to 0, because 0 divided by 3 is 0. And I'm going to add 5 to both sides, so 2x is equal to 5. Divide both sides by 2, x is equal to 5 halves, or 2.5, or 2.5. Now, if I look on my screen, where x is equal to 0, that's right there. And then x is equal to 2.5, that's right there. So this checks out. So this equation hits the ground at these 2 spots. I'm now going to go do the next problem in the calculator, and that will unfortunately erase everything I've written so far. But here I have my x squared. I'm doing problem 2 now. I'm going to use a little 2 key, the little square key above log, minus 12x plus 20. And then we're going to hit, whoop, I forgot my x there. Sorry about that. and then I'll hit my graph and see what it looks like. Looks like it intersects the graph at positive 2 and positive 10. Well, let's do our factoring and show you how that comes out. The first thing I'm going to do here is I'm going to think about this as a trinomial, and this is an easy trinomial, so I should think of all the factors that make 20. And my goal is to try to get a negative 12 here, so I'm going to try negative 1 and negative 20. That doesn't make a negative 12. Negative 2 and negative 10. All right, well, there's my match. So this gives me x minus 2, x minus 10 equals 0. Now my goal is to try to get my answers for when x hits the ground, or when this parabola crosses the x-axis. So I go to my graph of x minus 2 equals 0 and x minus 10 equals 0. Solve for x for each of these. X equals 2 and x equals 10. And I can see from the picture here that my graph intersects at both of these spots. So the calculator is really useful in checking your answer, but I do require all this work on the test, so it's not like you can just look at it on the calc and get the right answers and get full credit. All right, let's look at problem 3. And so today's work, as if you haven't figured it out already, is going to be a bunch of this, where I go to my calculator and I type in my x squared plus 2x, or my equation. I'm going to evaluate where that is shown on the graph. This looks like it intersects at negative 7 and positive 5. And now I'm going to go through and show my work on how I would get that using factoring. So here, this is a negative 35. This is an easy factoring problem, so I'm just going to take a look at all the ways I can get to that answer. Okay, so let's see, 1 and 35. I want that to be negative. Nope, that isn't going to work. Let's see, 3 is not divisible into 35, so I'm going to go to 5. So negative 5 and 7 is my combination that works. So x minus 5, x plus 7 equals 0. And what I will do then is I'm going to solve for x then. X minus 5 is equal to 0. X plus 7 is equal to 0. So my x is equal to 5. X is equal to negative 7. And so there's my answer, and there's my answer. Pretty nice, pretty nice. Let's do problem 4. All right, so in my y equals, I'm going to go and clear that out since it's a much shorter equation. 9x squared minus 144, and then hit graph. All right, looks like it's going and hitting the graph in 2 places here. So let's go and find out what happens here. So go to my screen draw. Now this happens to be a difference of squares, and so this would be 3x plus 12, and this would be 3x minus 12. I identified that at the beginning because there were 2 terms. The x squared was perfectly rootable, and so is 9 and 144. And the difference of square root gives me this. So I'm going to have 3x plus 12 equals 0, and 3x minus 12 equals 0. Subtract the 12 from both sides, I get negative 12. X is equal to negative 4. Add the 12 to both sides, I get 3x is equal to 12, so x is equal to positive 4. So here's my positive 4, here's my negative 4. All right, pretty good, pretty good. Now, the next problem needs a little bit of manipulation before I get started. What I have to do for problem number 5 is I have to move the 40x to the other side. So when I type in this equation, it's going to be x cubed. Now use the caret key above the division sign to put your little 3 there in the corner, minus 3x squared minus 40x. All right, so with that in mind, we are going to now graph this, and since it's a cubic, it can have up to 3 answers. It can have 1, 2, or 3 answers, or 0 answers if it's not factorable, but cubic's always going to cross that x-axis at least once. So there's 1, 2, 3 crosses, and it looks like it crossed at negative 5. It looks like it crossed at 0, and it also looked like it crossed at positive 8. So let's go and check out our work here and see what happened using factoring. So we take our x cubed minus 3x squared minus 40x is equal to 0. The 40x gets moved to the other side. Then to factor this, I notice they all have a common term of x, which I will then remove and set that equal to 0. Now what I will do is see what two numbers multiply to make negative 40 and add to make negative 3. Well, since I want a negative number here, the second number will be negative. And looks like I don't have it yet. Dividing by 3 doesn't work. Let's see, divided by 4. That's going to give me that. That's not going to work. Divide by 5. Let's see, 5 and negative 8. That works. So that's my combination. My x is still sitting out in front. So I've got x plus 5 and x minus 8. So now I have three solutions to this problem. X equals 0, because this whole thing was set equal to 0. X plus 5 equals 0. And x minus 8, which I'll write as plus negative 8 equals 0. So this is going to be x equals negative 5. And this is going to be x equals positive 8. So we can see that negative 5 is right here, 0 is right here, and positive 8 is right there. Whew, all right. Time for the next problem here. We're going to take a look at a difficult factoring problem. But this difficult factoring problem here is going to, there we go. This difficult factoring problem, we're going to first of all type in 3x squared minus 8x, and it's difficult because the first term is not a 1, plus 4. I notice I have some other stuff here. I just hit delete to clear that off. Let's look and see where my answers are. Looks like my answers are kind of hard to read. So this is where maybe the graphing calculator method isn't going to give you all of the right answers all the time. All right, let's go to my screen draw here and take a look at how I'm going to get my answers to work out. So the first thing I would do in a tricky trinomial is to take my 3 times 4 and multiply it to make 12. Now I'm going to try the factor that would make a negative 8 in the middle. Since I want a negative 8, the larger number will be negative. That's not going to work. Let's try 2 and negative 6. Negative 2 and negative 6. I think both of these need to be negative to make a positive 12. So negative 2 and negative 6 makes my combination of negative 8. All right, so I split this up into negative 2x minus 6x. I'm going to put my plus 4 here and my 3x here equals 0. So now what I'm going to do is see what I can factor out of the first two terms here, which I can only factor out of x. So this is going to be 3x minus 2. And the only thing I can factor out here is going to be a minus 2, which is going to give me my 3x minus 2 combination, equals 0. The matched parentheses go together, 3x minus 2, and the unmatched parentheses, or unmatched terms, go into their own parenthesis. So now I have my two answers, and we're going to see how they make this on the screen. So I go x minus 2 equals 0, so x is going to be equal to positive 2. My 3x minus 2 is going to be equal to 0. Move my 2 over, so 3x is equal to positive 2. Divide, and that gives me x is equal to 2/3. So you can see now that on my screen, it's very hard to see, but my intersection is at positive 2 and at 0.6 repeating, or 2/3. So that's where sometimes the graphing calculator cannot help out. Now, in this next problem, problem number 7, I'm not going to be able to type this into the graphing calculator first because it's technically equal to 14. So to kind of cheat for that a little bit, I'm going to put my x minus 3 in first. You see, I can actually type this in like you see it, which is pretty cool. And then my x plus 2, and then I'm going to subtract the 14 from both sides. So now here's what the graph looks like. It looks like my answers are going to be negative 4 and positive 5. Let's go check that out. Let's see how we do that using our factoring skills. Okay, so with this in mind, I'm going to do the thing that I just did, which is I'm going to bring the 14 over. So I'm going to have my x minus 3, and then my x plus 2, and then I'm going to have my minus 14 over, because I really want to set this equal to 0. Now I do need to FOIL this out. So x times x is going to be x squared. X times plus 2 is going to be 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. And the minus 14 is still there. I have some simplification to do. So my x squared is going to not simplify with anything. This is going to be negative x, and this is going to be negative 20 equals 0. Now I can factor this. I can factor this to find my two answers on the screen. And some of you may have already guessed that based on the answers on the screen, which is positive 4, or negative 4 and positive 5, then this is going to be x equals negative 5 and x equals positive, or x is positive 4. These are the two numbers that multiply to make the negative 1 in the middle. But you could have figured that out by making a little table chart with negative 20 there. But there is a pattern between some of these easy factorable problems and the answer on the screen. So now that I have x minus 5 equals 0 and x plus 4 equals 0, I solve for x by moving the numbers to the other side, and so I have my negative 4 there and my positive 5 here. Whew, let's go to the next problem. Okay, problem number 8. Now what's nice, again, about the graphing calculator, you can just type this in, like so. You can just go to, you can go x times the quantity of 1 plus 21x, and close it off, and then hit graph. Now on this problem right here, you'll also not be able to really see where some things are on this screen. Oh, you know what I forgot? Shoot. Did you notice that this graph was set equal to 10? Well, what we have to do there is we have to bring things over to the other side. So we're going to have to bring this over. We're going to have to minus the 10 right there. So taking a look at the graph now, we have two different solutions. And wow, I can't see those because those are unfortunately decimals on the screen. So this right here is the way you have to type the equation in, and this right here is how you graph it. Now let's figure out how to get those two solutions. So again, looking at this over here on the screen, I've got x, and I've got 1 plus 21x, and I've got minus 10 equals 0. So how does this mess get worked out? Well, we multiply everything by x, so we have x, and then plus 21x squared, and then minus 10 equals 0. Well, what this also means too is that we have to now rearrange this order, so 21x squared plus x minus 10 equals 0. Well, there's no way around this, folks. We've got to do this the tricky method. The 21 times the negative 10 gives me negative 210, which is going to give me a lot of different answers here to try to find that number in the middle. Now, it's unfortunate that we can't actually use any kind of shortcut on this because 21 is not a rootable number, so we just have to start listing these out here. Now, since we're trying to find that middle number of 1, let's start off with the simple solution 1 and 210. And so that's not definitely going to work here. 210 divided by 2 is 2 and 105, and that's still not going to work. 210 divided by 3 is going to be 3 and 70. Well, that's not going to work either, because we're still a long way from getting 1 in the middle here. And again, dividing by 4 gives me a decimal. 210 divided by 5 gives me 42. So at least we're moving closer together pretty quickly here. So dividing by negative 5 gives me, hold on a moment, 42. And then 210 divided by 6 is 35. We're getting closer, folks. Negative 6 and 35. 210 divided by 7. That's 30. So negative 7 and 30. Still doesn't give me 1. 210 divided by 8 doesn't work. 210 divided by 9 doesn't work. 210 divided by 10 is 21. So negative 210 and 21. Oh, we're not getting close. 210 and 11 doesn't work. 210 and 12 doesn't work because 12 is a decimal. 210 and 13 doesn't work. 210 and 14 works. So we're finally down to negative 210 and 14 and 15. Woo! So we split this up into negative 14x and positive 15x minus 10 equals 0, and 21x squared. What we can factor out of the first two terms here is going to be a 7x, and that leaves me with 3x minus 2. And then we're going to factor out of these next two terms, the 15 and the 10 here, we're going to factor out a positive 3, which is going to give me, positive 5, not 3, which is going to give me 3x minus 2 equals 0. And now our two answers are going to be 7x plus 5 equals 0, and 3x minus 2 equals 0. And you can now see why these are unreadable on the screen. If I move the 5 to the other side, I got 7x equals negative 5. X is equal to negative 5/7. I move the 2 over to the other side, I got 3x is equal to 2. Divide both sides by 3. X is equal to 2/3. So negative 5/7 is right there. And positive 2/3 is right there. Whew, good luck seeing that from the screen, right? All right, 2 more problems to go.